Hello, folks. Well, welcome to Chapter 13. I hope that Chapter 12 went fine for you, and now we're going to start Chapter 13, Spinal Cord, Spinal Nerves, and the Reflexes. Recall from Chapter 12 the organization of the nervous system, the central nervous system and peripheral nervous system. Central nervous system was brain and spinal cord, and the peripheral nervous system was the spinal nerves and cranial nerves. So this chapter is going to cover a little of the central nervous system, the cord, and a little of the peripheral nervous system, the spinal nerves. And then chapter 14 is going to cover the cranial nerves, so you'll get it all. But let's get started on chapter 13, the spinal cord and the spinal nerves and reflexes. So what we have here is the peripheral nerves, the spinal nerves, they're going to carry sensory input into the central nervous system, and you already know that. And then some of this input is going to have some automatic responses, and these are called reflexes, and we'll talk a lot about the reflexes. And of course, some of our responses will be conscious and controlled and voluntary, and we'll also talk about that. Chapter 13 covers the spinal reflexes that don't need the brain. Now, information does go to the brain, so we do become aware of these reflexes, but we don't need the brain. These reflexes would work if your spinal cord was cut above the processing area. And then in chapter 14, we will talk about some cranial nerve reflexes. We'll talk about some of those as well. So we'll be talking about all of it. Let's just do 13 for now. Now, fortunately for this chapter, it's really going to go quick because a lot of this stuff is anatomy. But I do want to point a few things out, and I'm not going to repeat everything you're going to learn in lab, but I do want to point a few things out to you, and you might hear it again in lab, but that's fine because we'll just reinforce it. So this is your spinal cord, and your spinal cord, as you're going to learn in lab, uh, runs from your medulla oblongata down to about L2. So your spinal cord stops right about here. Now I say your spinal cord stops right about there, but some of the nerves coming out of it continue downward, and really what happened was your vertebrae kept growing after your spinal cord stopped. So these roots were really coming out where they're named, like this S1. Well, the sacral vertebrae used to be way up here. So it was coming out at the same level. But your vertebrae kept growing, and they grew and grew and grew, but the spinal cord was done growing. So now these roots were elongated down. And here's like where your S1 nerve comes out of your sacral vertebrae and your S2 comes out here. But the origin of this S1 and S2 was way back up here near the L1, L2 region. But even the nerve up here near the L1, L2 region will be called S1 if it exits the vertebrae by S1. So that's how that works. Now there are a couple enlargements in the spinal cord, and these are areas where it serves a big area, like the plexuses that are going to go to your pectoral girdle and your pelvic girdle. So the first enlargement you're going to see is right here, and it's called the cervical enlargement. The next enlargement you're going to see right here is called the lumbar enlargement, right there. These are enlargements of the spinal cord that are going to give rise to some plexuses that serve the girdles of your body, the pectoral girdle and the pelvic girdle. Uh, in addition, let me point a couple other things out. Your roots here, the dorsal root is sensory neurons going in. Your ventral root is motor neurons coming out. And that means that this spinal nerve right here is a mixed nerve because it contains the sensory neurons going into the spinal cord and it contains the motor neurons going out of the spinal cord. Now what's happening right here, this area right here? Well, this might synapse directly. The sensory nerve might synapse with the sensory neuron might synapse directly with the motor neuron, or you might have an interneuron in there. Either could be true. The anatomy of the cross section of the spinal cord right here with the horns of the gray matter and the columns of the white matter. I'll leave that to the lab. We'll learn what this butterfly-shaped gray matter, all the horns are called, and the commissures. And with the white matter, we'll learn what the columns are called. I will tell you this before we go on, that columns in the white matter are also known as funiculi. And there's tracks within the columns, and the tracks within the columns of the white matter are called fasciculi. Fasciculi. So funiculi are columns and fasciculi are tracks. A couple more things. Right here at the bottom of my coccygeal nerves, I have this thing called the filum terminale. And that filum terminale in this coccygeal ligament is really a continuation of one of the meningeal layers that surround my spinal cord. It's a continuation of the pia mater. And it does come down and hooks to the coccygeal region of your skeletal system. It hooks to the coccyx. So the filum terminale is a continuation of your pia mater. All right, that's about it for the spinal cord. A lot of this other stuff like counting the spinal nerves, you certainly will learn in lab. Be advised that there's 3 layers of meninges covering the spinal cord, as there are 3 layers of meninges covering the brain, and they're continuous with each other. The outermost layer is called the dura mater. The middle layer is called the arachnoid mater, and then the layer that tightly adheres to the spinal cord and brain and follows all of the contours of the spinal cord and brain is called the pia mater. So these are 3 meningeal layers. Singularly, each one of these is called a meninx, and a plural is meninges. So meninx and meninges, that's singular and plural for this word. Just so you know, there's a subarachnoid space. So there's a space between the arachnoid mater and the pia mater, and that subarachnoid space contains cerebrospinal fluid, as does this central canal right here, the central canal of my gray matter. So there's some cerebrospinal fluid bathing my spinal cord in here, and there's some cerebrospinal fluid in the middle of my spinal cord in the central canal. However, by the time you hit adulthood, the cerebrospinal fluid in the central canal probably is gone, and the central canal is probably collapsed. That's true for most adults. But as a child, the central canal is certainly open and filled with cerebrospinal fluid. You can see that there's an epidural space right here. Epi means on top of, dura means the dura mater. So there's an epidural space right here containing adipose tissue, fat tissue. You've probably heard of epidurals before, where they put an anesthetic in your epidural space, and it acts as anesthesia, an analgesic or an anesthesia, numbing some of the neurons of that area. So that's the epidural space. You can see the subarachnoid space right here from this cut, and there, that's where the cerebrospinal fluid would be, and of course it's bathing the spinal cord. You can see that there's one big epineurial lining. You can see this big epineurial lining. Actually, I'm sorry, that's not the epineurial lining. That's the dura. You can see that there's a big dura covering both my dorsal root ganglia and my ventral roots, so you can't see both the dorsal root ganglia and ventral roots from this cut, but over here you can. Over here you can see the dorsal root ganglia right here and the ventral root, and it's all covered by this dura right here, so you can see that. All right, moving on.
There are 31 pairs of spinal nerves, named according to their related vertebral levels. There are 8 cervical, 12 thoracic, 5 lumbar, 5 sacral, and 1 coccygeal. Each spinal nerve is connected to the spinal cord by a series of rootlets. The rootlets on the dorsal surface of the spinal cord converge to form the dorsal root, and those on the ventral surface form the ventral root. A dorsal root contains bundles of nerve fibers carrying sensory or afferent information from the skin to the spinal cord. The cell bodies of these fibers are located within a swelling on the dorsal root, called the dorsal root ganglion. Each ventral root contains bundles of motor or efferent fibers, carrying impulses away from the spinal cord to the skeletal muscles. The cell bodies associated with these fibers are located in the ventral horn of the spinal cord. The dorsal and ventral roots unite to form a short spinal nerve in the intervertebral foramen. Because sensory and motor fibers of the roots mix together in the spinal nerve, they are known as mixed nerves. After emerging from its intervertebral foramen, each spinal nerve divides into two branches, called the dorsal ramus and the ventral ramus. Dorsal rami innervate the muscles and skin of the back. In contrast, ventral rami innervate the lateral and ventral skin of the trunk, the skin of the limbs, and the muscles of the trunk and limbs.
Okay, so that video just told you that there was 31 pairs of spinal nerves and 8 of them were cervical, and that's where it differs from your vertebrae because there's only 7 cervical vertebrae. So as a rule, your spinal nerves come out below their vertebrae. Like the T1 spinal nerve comes out below T1 vertebrae, and T2 below T2, and L5 below L5, etc. But there's 8 cervical nerves and there's only 7 cervical vertebrae. So in lab, I'll show you how the C1 cervical nerve comes out above the atlas, and the C2 cervical nerve comes out above the axis, and the C3 cervical nerve comes out above C3, and C7 cervical nerve comes out above C7, and then C8 cervical nerve comes out below C7, and then T1 below T1, and so on and so forth. So that's a lab thing, and I just wanted to explain it because I didn't want the video to be confusing to you. So this is a lot of anatomy right here, and again, this is lab stuff, but I do want to point out one thing, that as the sensory nerve comes in through here, the dorsal root ganglia, and into here, these are sensory nuclei. Now, why do I want to point that out? Well, because I want to point out 2 words. What is a nuclei? And by the way, what is a ganglia? Because they really are the same thing. Well, I'm not talking about a nucleus of an atom that's protons and neutrons at all. The furthest thing from that. What a nuclei is in the nervous system is a collection of soma in the central nervous system. Collection of soma in the central nervous system. So as my sensory neurons come in, they're going to synapse with sensory nuclei right here in the gray matter. So that's a synapse right there, because the soma of my sensory nerve is here in the dorsal root ganglia. That's one of those unipolar nerves here in the dorsal root ganglia. But the axon has axon collaterals and telodendria, and they synapse with interneuron sensory nuclei here. And I can see in my gray matter that I actually have an area that has somatic sensory nuclei, and I have an area that has visceral sensory nuclei. And so the somatic sensory nuclei and visceral sensory nuclei are separated in the spinal cord. There's organization there. And then these interneurons are going to synapse with motor neurons that are going to leave through the ventral root and go out to my muscles. But the soma of my motor neurons exist here in the gray matter, and there's a pool of soma called visceral motor nuclei, and there's a pool of soma called somatic motor nuclei. The visceral motor nuclei belong to the autonomic neurons, and the somatic motor nuclei belong to the somatic neurons. They go to skeletal muscles. So the autonomic neurons go to smooth muscles, and the somatic neurons go to skeletal muscles. So there's organization here. With the gray matter, and there's organization, by the way, with the white matter, but I'm just showing you the organization of these nuclei. Now, I showed you what nuclei were, a collection of soma in the central nervous system, but I said to you a few seconds ago that a ganglia and a nuclei were the same thing. Well, what's a ganglia? It's soma, a collection of soma in the peripheral nervous system, and we'll talk about a lot of ganglia. So that a ganglia and a nuclei are the same thing, a collection of soma. But a nuclei is a word retained for the central nervous system, and a ganglia is a word retained for the peripheral nervous system. This just shows you a true histological picture. You'll be looking at this in lab. You can see that it looks very, very much like the artistic drawing. Sometimes that's not true, of course, but this is very true, and you can see that the histological cut or section looks just like the artistic drawing here. Oh, before I go on, why is gray matter gray and white matter white? Well, you probably already know this, but the gray matter is gray because it's an unmyelinated area, and the white matter is white because it's a myelinated area. So that makes sense that the nuclei are in the gray matter because we don't myelinate our soma. But we do myelinate many of our axons, and of course not all of them, but many of them. So the gray matter is gray because it contains sensory and motor nuclei, both somatic sensory and visceral sensory nuclei, and it contains both somatic motor and visceral motor nuclei. So the gray matter is gray because it's largely unmyelinated, whereas the white matter is white because it's largely myelinated.